Hey guys, welcome back to Math from my desk. And in today's video, we'll be covering subtopic 1.1 of IB Math AA and IB Math AI, which is scientific notation. So before we get into the actual topic, let's first discuss why we study scientific notation. So the distance from the sun to the earth is a really big number, 1496 followed by 8 zeros meters. And likewise, you can also have really small numbers, like the mass of a proton, which is 0.0000 followed by a ton of zeros, then 16726 kilograms. So in the universe, we have really big numbers. We also have really small numbers, and these can be hard for scientists to write. Well, not necessarily hard, but it can make them prone to error. Say they forget a zero or they misplace a decimal point. So scientific notation is a way to write these really big or small numbers in a simple manner. Or in other words, it's the language that scientists and mathematicians use to talk about the scale of the universe. So really big things like distances between planetary bodies are really small things like the mass of a subatomic particle. So now what is scientific notation, the definition? So the definition or the standard form of scientific notation is going to be a times 10 to the k. So a right here is the coefficient. It will include all the significant digits in your number, and this value a will always be, in your final answer, it will always be greater than or equal to 1 and less than 10. So for example, say your number is 149600, your a value is going to include all your significant digits and is going to be between 1 and 10, so that would be 1.496. So 1.496 would be your a value. Then we have times 10 to the k. So this value k right here, it's the order of magnitude, and it basically tells you how many places you need to move your decimal point. So you can see this times 10 as representing zeros, and this k is telling you how many places you need to move your decimal points and also in which direction you need to move it. So k is always an integer, so it is either a positive or negative whole number. So if it is positive, that means that in order to go back to your original number, you're going to move your decimal points to the right. And if it is negative, in order to go back to your original number, you're going to need to move the decimal points to the left. So let's go through an example for a conversion process. So we have an extremely large number. This is the number that I showed you guys before, the distance from the Earth to the Sun, 1496, then followed by 8 zeros meters. So step 1 is going to be to identify the coefficient. So our coefficient a is going to, first two things, it's going to include all of our significant digits, so non-zero digits, and in this case that is 149 and 6, and it is going to be greater than or equal to 1 and less than 10. So we should place our decimal point right here as 1.496, that is between a and 10. If we had 14.96, that wouldn't fit our criteria, neither would something like 149.6 or 0.1496. So 1.496 fits our criteria. So we have 1.496 as our a. Next, we need to determine our exponent k. So our original decimal point is here, right? And in order to determine our exponent k, we want to see how do we get from here, so where we're putting the decimal points for the standard form, 1.496, to the original decimal point. So how many places do we need to move and in what direction? In this case, we're moving to the right, so our k value is going to be positive, and let's count how many decimal points we're moving. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our k is 11, and then step 3, that's going to be build the expression. Remember, the standard form is a times 10 to the k, so we're going to have 1.496 times 10 to the 11. And this is how you convert the distance from the Earth to the Sun into scientific notation. So the distance from the Earth to the Sun is 1.496 times 10 to the 11 meters. So here we have another example, but with a small number. So we are converting the mass of a proton to scientific notation. So step 1 is going to be to identify the coefficient. So our significant digits are here. They're 1, 6, 7, 2, 6. And since we want our a to be greater than or equal to 1 and less than 10, we're going to place the decimal point, the new decimal point, right here. So we're going to have 1.6726 because this is what makes our criteria right. If we had the decimal points, for example, here, then you'd have 16.726, which does not fit the criteria that 1 is less than or equal to a is less than 10. So this is why we have 1.6726. So that's step 1. Now step 2, we want to determine our exponent k. So now if we want to move from 1.6726 to our original number, so our original number is right here, our original decimal point is right here, we're moving to the left, so that tells us that k is going to be negative. And let's see how many places we're moving. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So our k is going to be negative 27 since we're moving to the left. So that is step 2. And now step 3 is simply build the expression, a times 10 to the k, 1.6726 times 10 to the negative 27 kilograms. And so this right here is the mass of a proton. So pay attention to this potential mistake. So in an IB exam, you cannot use your calculator notation. So what is your calculator notation? So for example, what we found, for example, before, the mass of a proton, I think that was 1.6726, right? Times 10 to the negative 27 kilograms. Your calculator, it will not write times 10 to the power of. It will write instead 1.6726 e negative 27. And all this e is times 10 to the power of. So these expressions are the same. However, in an IB exam, you cannot write e. You must write times 10 to the power of. So this right here comes directly from the syllabus guide of the IB. So it says calculator or computer notation is not acceptable. For example, 5.2 E30 is not acceptable and should be written as 5.2 times 10 to the power of 30. So you want to ensure that you use the correct notation, otherwise you may lose points in your IB exam. All right, so now we can move on to mathematical operations with scientific notation. So let's go ahead and start with multiplication. So when you multiply two numbers in scientific notation, what you do is you multiply the coefficients, so the a's together, and you add or you multiply the exponents separately. The reason it says add the exponents is because our exponents are always going to be in the form of 10 to the power of k, right? And since you have the same base, 10 to the power of a multiplied by 10 to the power of b, that is 10 to the a plus b. All right, so let's do a quick example. So say we had 3.0 times 10 to the power of 8, and we want to multiply this by 2.0 times 10 to the power of negative 3. So we're going to go ahead and multiply our coefficients together, 3.0 times 2.0, and then we're going to multiply this by 10 to the 8 multiplied by 10 to the negative 3. Three times 2.0, that's easy, that's just 6.0. 10 to the 8 times 10 to the negative 3, that's just going to be 10 to the power of 8 plus negative 3, which is equal to 10 to the power of 8 minus 3, which is equal to 10 to the 5th. So the answer here is going to be 6.0 times 10 to the 5. It is this easy. All right, now we can move on to division. So the rule for division is that when you divide, same thing for multiplication, you're going to divide the coefficients together, and then you're going to subtract the exponents. So this is because, say you had 10 to the a, and you're dividing this by 10 to the b, the solution is going to be 10 to the a minus b. So the numerator exponent minus the denominator exponent. So let's have an example with, let's just say, for example, we have 8.0 times 10 to the 6 divided by 2.0 times 10 squared. We're going to divide the coefficients together, so we have 8.0 divided by 2.0, and we're multiplying this by 10 to the 6 divided by 10 squared. 8 divided by 2, that is going to be 4.0, times 10 to the 6 divided by 10 to the 2. That is the same thing as 10 to the 6 minus 2, which is equal to 10 to the 4. So you have 4.0 times 10 to the 4 as our final answer. Alright, so now we move on to addition and subtraction. So to add or subtract numbers in scientific notation, their exponents must be the same. So this is similar to, for example, needing common denominators to add fractions. So, for example, let's perform this operation, 4.5 times 10 to the 6 plus 3.1 times 10 to the 5. So what we're going to do is we're going to choose the larger exponent to be our target. So in this case, that is 6 right here. And we're going to want to turn this expression, 3.1 times 10 to the 5, into some coefficients multiplied by 10 to the 6. So since we're moving, or we're increasing our exponents by 1, that means that we're going to move our decimal points to the left. We're going to decrease our coefficients. So we go from 3.1 to 0.31. And you might wonder, well, this doesn't fit, or you might ask yourself, this doesn't fit the criteria that 1 must be less than or equal to a must be less than 10. And that is true, and that is actually all right to do when you are in the process of addition or subtraction. So this criteria will only matter for your final answer, your final product. So in this case, since you are in the middle of your operation, then you can absolutely do this. So we now rewrite this expression as 4.5 times 10 to the 6 plus 0.31 times 10 to the 6. We're going to add up the coefficients together, so you have 4.5 plus 0.31, and then we simply multiply this by 10 to the 6. And 4.5 plus 0.31, that is 4.81, and then you have times 10 to the 6. And this right here is our final answer. All right, now we have some quick TOK. I know TOK is not IB students' favorite class, but some quick TOK that was in the IB syllabus regarding scientific notation. So, do the names that we give things impact how we understand them? For instance, what is the impact of the fact that some large numbers are named such as the googol or the googolplex? And if I'm not wrong, the googol is something like 10 to the power of 1,000, but I'm not quite sure. While others are represented in this form being scientific notation. So if you guys are interested, you can go ahead and think about this and answer in the comments, or you can go ahead and read, you can read what AI thinks right here. So I gave this prompt to AI and I asked it specifically what it thinks of this. So you guys can take a minute, pause the video, and read this. All right, well, thank you guys for watching. This is all for today's video on subtopic 1.1 scientific notation. Please like and subscribe if you were able to find this video helpful, and I'll see you soon, guys, as we continue the IB math syllabus for both analysis and approaches and application and interpretation.